All right, one final interesting example to conclude here. So first, you can see the function we're dealing with is natural log of x. So then the derivative is 1 over x. And if we happen to evaluate that derivative at 1, we get 1. Okay, so then now here's the interesting thing. All right, so let's see, it says using the definition of the derivative at x equals 1, we have, so this is 1 would equal f prime of 1, as we already know. Okay, what are you doing, Professor Bright? This is the same as what we already know. So then this would be, if I look at natural log and the definition of the derivative of that, this would be the limit as x goes to 0 from the right of f of 1 plus x minus f of 1 all over x. Okay, so then just continuing this would be, okay, limit as x goes to 0 from the right, this would be natural log of 1 plus x, and then minus natural log of 1. Okay, that's just definition derivative all over x. Okay, but then this goes to 0, right? Natural log of 1 is 0. Okay. So then really this is the limit as x goes to 0 from the right of 1 over x times natural log of 1 plus x. Okay. Why is this helpful? Well then, right by log laws, I can say that this is limit as x goes to 0 on the right-hand side of natural log of 1 plus x to the power of 1 over x. Okay, and this is all still, 1 along the way here. Okay, now what we're going to do is at this stage, we're going to exponentiate each function. And we can do this because the exponential function is a continuous function. Okay, and so then what we get, oops, I don't want the e there, I want the e there, right? I need to apply it to each side in its entirety. Okay, so I would get, on the left-hand side, I would just get e. Right-hand side, I'd have e to the limit as x goes to 0 from the right, natural log 1 plus x to the power of 1 over x. Okay, and then the e can move inside, right, because it's a continuous function. And so this would be e is equal to, let's see, I'd have limit as x goes to 0 from the right of e to the natural log of 1 plus 1 over, or 1 plus x to the power of 1 over x. And these would simplify. And so I get e is equal to the limit as x goes to 0 from the right of 1 plus x to the power of 1 over x. Okay, that's kind of fun. Okay, and now, just for fun, why not? If we let n equal 1 over x, then we can get it written as e is equal to limit as n goes to infinity, right? If 1 over x approaches 0 from the right, and this n will tend towards infinity. And then we have 1 plus 1 over n to the power of n. Okay, so you have now 2 more ways of understanding this natural number e, depending on which form of a limit you want to look at. Okay, so there you go. We have 2 more ways to understand e, and it made use of the logarithmic or log derivatives that we already know. Okay, so there you go. We have finished our section on derivatives of logarithmic and inverse trig functions.